Elasticity. Today we are going to discuss about elasticity in this lecture. We are going to start it with the rigid body. Rigid body. What do you understand by this? Rigid body. Look, this is body, okay, but just a rigid word is added. Rigid word is added with the body. It will tell you exact meaning of rigid body. Let me drop this ink with this marker. There are some concepts that we need to understand for this chapter. Some topics that are stress, strain, types of stress, types of strain, modulus of elasticity, coefficient of elasticity, ratio of stress and strain. All these topics that we need to understand for this. Important topics will not be ignored at all. Not at all. I have PPT as I take always PPT for the lecture. In this lecture also I have PPT. First of all I will read. Whenever it will be requirement to read the PPT, I will be reading. Rigid body. In my language I can explain it. But we needed to see what is PPT saying. Okay. PPT is saying a rigid body, a body whose size and shape cannot be changed. Means एक ऑब्जेक्ट है जिसकी शेप और साइज चेंज नहीं किया जा सकता. Shape. It means that body is hard. Am I correct? That body is not flexible. That body is hard because it does not change its shape and size. That's why this is hard. However large the applied force, mean जितना भी फोर्स लगाया जाए, अगर वो अपने आप को डिफॉर्म ना करे, बॉडी डिफॉर्म ना करे, उस बॉडी को रिजिड बॉडी कहा जा सकता है. डिफॉर्म मतलब however large the applied force may be is called what? Rigid body. Try to understand. Simple, you can say amount of forces are being applied on the object, but what is happening? Body is not changing its shape and size. This is what is the definition of a rigid body. Okay, it does not change size and shape. Whatever will be amount of a force doesn't matter. Body is hard. Okay. There are some more points for this that are taught in rotational chapter, but right now this is enough for rigid body. This is a type of body which is a hard. Hard means it does not change its shape and size. Whatever will be amount of a force doesn't matter. Okay. Now there is no perfectly rigid body. Remember, it's a fact. It's a fact. In our nature, in our world, if you take an elastic object or rigid object, you will see that a rigid body is not perfectly rigid. Try to understand. Any body is not perfectly rigid. Just we assume that yes, body is rigid and Based on rigid body, we see ahead words or you can say topics related to rigid body. Just you assume that body is a rigid, but when it comes to facts, we know that in our nature there is no exact or perfect rigid body. Okay. Okay. The nearest approach to a perfect rigid body is a diamond. Try to understand. It tends to perfect. It will tend to perfect tendency. Do you know about the tendency? Means it is not equal to zero, but it wants to become zero. This is what is meaning of a tendency. So rigid body wants to tendency what? Perfect, but it does not become perfect. This is what is meaning of a tendency. Okay, approach, or you can say approach. Now next word we have, which is a deformation force. Deformation force. You can say this is a force, but what kind of a force? Deformation. I know a deformation word is new for you, but it is not compulsory to ignore it. Yeah, it is compulsory to understand instead of ignoring this. Deforming means we are applying force. When we apply force, what happens with the object? When force is applied on the object, then that object can change what? Their shape, or you can say configuration. It will be good to say configuration word, to use configuration word instead of shape, size, volume. Okay, configuration will contain all this: shape, size, volume. Configuration word I will use. So deformation means this is a force which is applied on the object, and when force was applied on the object, if object changed its configuration, then we will say yes, this was a deformation force when object changed its configuration. Okay, so it's nothing but we will apply this type of force, we will apply on the object, then you will see yes, object changed its configuration. On the other side, you will observe there are some objects when we are applying force which is a deformation force on object, then what is happening? That object is not changing its configuration. This kind of a force we get, even we see in our world. So this type of a force will be something else. Okay, something else. It can be plastic object. So elastic is nothing but when deformation force is applied on the object and it changes its configuration. Okay, then this type of object is known as elastic. But we are understanding about the deformation, not the elastic. So deformation is nothing but this is a force which is applied on the object. Then object tells us that yes, I changed the configuration or not. So who will tell? Object will tell. Okay. Without moving, it as a whole is called deformation. This is also enough for deformation. Now next we have word which is restoring. Restoring force. Restoring means restore. Restoring of a force. That all. This is also force, but difference between them is between a deformation and restore. First of all, let's understand what is a restoring force. What is a restoring force? We are crystal clear that it's a force, okay? We know that it's a force. But word which is added with this force is what? Restoring. What is the meaning of this restoring word? It is saying this is an internal force, okay? This is the internal force of the body, not external force. External force That is that force which is applied by the object or by the person, non-living thing or non-living thing. But restoring force is not external force. It is an internal force that is present inside object. Okay, that is present inside, or you can say that is created inside object. Clear? First, you know that this is applied, this force, restoring force is applied by the object which is present inside the body. Clear? Now, why does object apply this restoring force? Answer is they want to regain its configuration, or you can say it wants to regain shape or size. Okay, it will happen when deforming force will be removed. Then object will be able to regain its configuration, and when this force will be applied by the object, this type of a force is known as restoring force. Okay. Now, Pevita is saying, in equilibrium, magnitude of a restoring force is equal to the deformation force. Means, either body will be in a rest or will be moving with a constant speed. This is what is the meaning of the equilibrium. Means body is in equilibrium. In that situation, magnitude of restoring force will be equal to what? Deformation force. Yeah, even you observe in your real world, whatever force is applied, which is external force on the object, then of course that much force object will apply, which is present inside the object. Okay. Now next point for this is the restoring force at a point do not action reaction pair with applied force. This restoring force will not obey action reaction pair at a point. This force is responsible for the elastic nature of the body. Restoring force. Restoring force, we can say restoring force is a compulsory for elastic body. Even we will see this word when we will be discussing about elasticity. Then you will see that I am using restoring force word. That's why it is being said that this force is responsible. It will tell you, is body elastic or not? Who will tell you? Restoring force. Okay. Next we have elastic behavior of solids. Means what are elastic behavior of solids? We are not taking fluid, we are not taking liquid or gas, but solid. So what is the elastic behavior? What should be elastic behavior of solids? Let's see. Do you know what is the elastic? In a solid, since we have a solid, atoms or molecules are bonded together by the interatomic, or you can say intermolecular force. Intermolecular is nothing but this is a force, intermolecular force, and to stay in the stable equilibrium position. I have explained what is equilibrium. When body or solid is in equilibrium, okay, when solid is in equilibrium, in that case the intermolecular force which will be applied by it on the object, then what will happen? They will come together. They will come together. But when deforming force will be removed, in that case, intermolecular force, or you can say atoms or molecules, will go away from to each other. This is what will happen when deforming force will be removed. But what if deforming force was applied? In that case, we will see that our atoms or molecules are stick together. This is what happens inside the body. Okay, and you can say it is a behavior of solids. It's a elastic behavior of solids. This was first point for this. Next point is when a solid is a deformed means solid has changed its configuration. This is what is the meaning of solid is a deformed. Okay. When solid is a deformed, the atoms or you can say molecules are then displaced from their equilibrium position. Try to understand. Of course, they will come together. They will come together. Displaced from their equilibrium position, causing a change in the interatomic distance. On the other side, we can say when the deforming force is removed, then what happens? What will happen with the atoms or molecules? We see the interatomic forces tend to drag them back to their original shape, or you can say configuration, original shape or original position. The object or solid will want to tend to the original position when deforming force is removed. It happens. This happens. These are 2 points that are elastic behavior of a solids. First we saw that when forces are applied, then deforming force, then atoms or molecules come together. Yeah, this was one point for this. Second point was when deforming forces are removed. In that case, we were observing that they go from to each other away. Means they want to go back their original position. Okay. Next, we came to the main topic, which is elasticity. Before this elasticity, we saw about rigid body, deformation force, restoring force, elastic behavior of solid force. These were important for understanding elasticity. Okay, that's why I was discussing about this. So remember, elasticity is nothing but this is material, or you can say body or object or substance. Elasticity is a body, but it will tell you that what kind of object you have. What kind of object? So who will tell you? Elasticity. Okay. We say that this board is elasticity. This device is elasticity. Means what are you understanding by this? Let's see. The property of the material, property of the body, property of the substance. This is a property of the body by virtue of which it regains its original size and shape when deformation force is removed. What did you understand? Try to understand. The property of material by which, try to understand, the property of material, for example, the property of this material, of this board, by which it regains its original shape or original size when deformation force is removed. Of course, if you don't remove deformation force, then what will happen with the object? You will see that that object is not coming to the original position or shape or size. This is what will happen when deformation force will not be removed. Will not be removed. So that's why it is best to say remove deformation force so that body can come to the original shape. Okay, so that body can come to the original shape, so that body can regain its configuration. Clear? That's why I am emphasizing on deformation when deformation force is removed. Okay, one more times about elasticity. Elasticity is nothing but the property of material, the property of any material by which try to understand, it regains its configuration when deformation force is removed completely. That is called elasticity. Yeah. Now next word, we have examples of elasticity: quartz, diamond, steel. All these have more elasticity. If I ask one question, is a does a rubber have more elasticity or steel? Tell me. You have two kinds of two objects. One is rubber and second is iron. My question is, which one object will have more elasticity? Answer is steel. Steel. Okay. So diamond, steel, rubber, all these are examples of elasticity. Now, note in a note, there is no perfectly elasticity. Remember, there is no perfectly elastic material. When we were discussing about a rigid body, then at that time we saw this word. We were saying here, rigid body is in our nature. Any rigid body, any body is not a perfectly rigid body. Yeah, that is what we saw. Same here we are observing that this word, this sentence is coming. It is telling you that whatever force you take, you will see that that object is not a perfectly elasticity. This sentence will come, I think, for 5 times. There is no perfectly elastic material. Okay. Exist in nature, but quartz is the nearest perfectly elasticity material. There is a one object which is quartz. This object, it is saying that I am near. This quartz is near to the plastic, perfectly elasticity. Okay, but quartz is the nearest perfectly elasticity material. Elasticity is a molecular property. We were talking about there is no perfectly elasticity. Elasticity is a molecular property of matter. I think it is enough for about for elasticity. Now let's move towards the topic, which is a plasticity. Just a point of this elasticity is our plasticity. Plasticity. Whatever we saw about elasticity, just opposite of it is our plasticity. Now you will see this word is coming again for plasticity. First of all, let me explain what is a plasticity. Again, the property of the material, the property of the body which does not regain. Try to understand. It is a property of the body which does not regain its configuration. When deformation force is removed completely, that kind of object we have in our world. We have two types of objects in our world. What first is elasticity type of object and second is plasticity type of object. But again, I would like to say that in our nature, there is no perfectly plasticity object. Did you hear? This plasticity is nothing but the property of the material which does not want to regain its original shape or size or position when deformation force is completely removed is called plasticity. Let's see examples of plasticity. Examples of plasticity. We have putty duff, soldering lead, chewing gum. Wow, chewing gum. Chingum. Examples: putty, duff, putty duff on wall. Okay, chewing gum. Okay. These are best examples of plasticity. Even you can take flour, wet flour. Okay, wet flour. When you will apply force on chewing or putty duff, you will see that we removed deformation force, but object is not coming at original shape. Okay. No material is perfectly plastic, but putty is the nearest approach. This putty is the nearest perfectly plastic material. And quartz is the nearest elasticity material. Clear? Okay. Now we are able to understand stress. This is not that stress which we take in our life. In physics, meaning of stress is completely different. Completely means completely. Don't think that this is that stress which people take. Okay? You are in the context of physics. So, meaning of stress is what? We saw plasticity, elasticity, restoring force, deforming force. But this word which came, stress, is what? Is what? Could you tell me? Let's read first of all what is PPT saying. I can say directly. I can say this is nothing but it is a ratio of force and area. Force and area. Force is a restoring force. It will tell you that how much restoring force is being applied by the object on per unit area. Okay. Who will tell you? We now restoring force, but per unit area. On per unit area. The internal restoring force which is being applied by the object on the object per unit area is our stress. Is known as stress. Okay. The restoring force which is acting per unit area of the deformed body. Remember, we have already applied a deforming force. Now, it's a work of object. Object will regain its original. It means object is going to apply force, which is a restoring force. We know that restoring force which is being applied will be on area, and we are taking per unit area. Restoring force per unit area will tell you stress. Formula is what? Force upon area. So force is nothing but stress is equal to restoring force upon area. Remember, we are taking force which is restoring, not deforming. Don't get confused over here, brother. Otherwise, you will face the challenges in your upcoming mathematics. So get clarity from here, from this part. This is force which is restoring, not a deforming force. Okay? And you can write it as a Fr upon A. Fr upon A. It's a dimension, it's a unit would be what? Its SI unit should be, I think, Newton meter per square. But when it comes to dimension, we now m is 0. No, m is not 0. M is 1. And L is how much? 1. So you can say dimension for this should be m1 L1 A minus 2. m1 L1 T minus 2. Got it? Got it. This was a dimension. Remember, this is valid. This F upon you now restoring force is equal to what? This restoring force is equal to external force. External force, or you can say internal force is equal to external force. So from here you can say Fr upon A is equal to Fex upon A. But this is valid when situation is in equilibrium, then this is valid. Okay? Then this is valid when object is in equilibrium. Got it? Got it. Now next, let's talk about types of states. Types of states. After understanding types of steps, we will understand about step. But let's complete first of all types of step. So that step can come to us. Types of steps. Types of steps. First we have longitudinal, longitudinal states. Longitudinal states. This is very simple. Longitudinal states, you can say it is a states. But one or two more word will come for this longitudinal states. When states is normal, this is normal. To this surface, let's suppose we have this object and we are saying this is a normal to the surface of this object. Even this can be normal, but right now we are considering this surface as a normal. Okay, when a stress is normal to this surface of the body, then it is known as a longitudinal stress. Here you will say that this will go upward. When let's suppose deformation force is applied on this object. Now what will happen? This will go upward, means a restoring force, and this is our area. You can see this is our normal, which is to the surface, and if normal restoring force is perpendicular, if a restoring force is perpendicular to the normal surface, then we will call it as a longitudinal stress. Okay, but remember, normal restoring forces should be perpendicular to normal. Okay, what did you understand? This restoring force should be perpendicular to normal surface. Then we will call it as a longitudinal stress. Once you understand longitudinal stress, this has also two types of longitudinal stress. First we have tensile stress, and second we have compressive stress. Compressive stress. This was nothing but normal to the surface and restoring force is a perpendicular. Okay, perpendicular. As you see types of stress, first comes longitudinal stress. Then you will see that longitudinal stress has two types of stress, two types of longitudinal stress. First is a tensile, and second is a compressive. Tensile means tension force. Okay, tensile means tension, and compressive means compression. From this word you will understand completely about tensile and compressive force. Try to understand. Let's suppose there is a object which is attached with a string, and the string is attached with a ball, with rope, you can say. So what will happen? You will see will see that this is nothing but tensile force. Here force is a downward. Force is a downward, which is nothing but mg. But upward force is what? Tension force. So tension force is being applied by the object. You can ignore string. Take this body. You will see that this is going downward due to gravitational force. If it is going downward, it will not completely downward, and then you will see that tension force is being applied on this object, so that it can regain its original shape. So tension force is applied so that it can come upward, and you know gravitational force is pulling downward. So over here our stress is a tension stress, okay, tensile stress, not a gravitational stress. So from what you try to understand, the longitudinal stress produced due to the increase in the length of a body is defined as a tensile stress. Of course, it will provide the length of the body. This will come here. So this will be our change in a length. Change in a length. Change in a length. Now one diagram for this tensile. There is a board like this, and a rod is attached with this board. Initially, this was the length of the rod. Initially, there is no deformation force. But when deformation force was applied on this object, then what happened? This came over here to this point. Now, from here till here, this is our delta L, which increased by the deforming force. Okay, when we applied a force on this object and this rod came to this point, this happened. So it happened due to deforming force. When you will remove deforming force, then what will happen? This object will come on this point, on initial point. Clear? So this is what? This is our tensile force. Tensile stress, not force. Del L, L upon del L. Now next types of longitudinal stress, which is a compressive. This is our ground, or you can say surface of the earth. We are taking an object. Let's suppose we are applying deforming force like this, perpendicular to the surface of the top surface of the body. What will happen? This earth will also apply force upward, and we are already applying downward force. In that case, what is happening? This is nothing but it is a compressing. We are compressing. Even we can use both hands to compress any object. You will see that this will go downward, not backward, not forward, but downward. The longitudinal stress produced due to the decrease. Here, in the case of a tensile stress, we were pulling the We were pulling rod. So this is nothing but pulling force. And compressive is nothing but pushing force. Here we apply force which is a pushing. When you will push the object, then what will happen? You will get length, but length will be decreased. So here length is decreased, and in this phenomena length will increase. This is what is the use difference for tensile stress and compressive stress. Clear? Tensile stress provides what? Increased length of the body. But compressive stress provides what? Decreased length in the body. Clear? Of the body, you can say. Now next type of stress, which is a volumetric stress. Volumetric stress. Volumetric stress. From volumetric word, anybody can understand. Even you can understand. Here, first word is added with stress, which is volumetric. It is telling you that volume of any body. You can take this object which is taken majority times in our school. Even I am taking this in front of you. This is a volume object. Here you can see. Here you can see. When we talk about volumetric stress, we think volume. We think about volume. Okay. When you will apply force on this body, then what will happen? You will get delta V, means change in volume. This is a definition of volumetric stress. But right now just understand. When force is applied from all sides on this body, then what will happen? It will decrease its volume. Am I correct? Yeah, it will decrease its volume. This is nature. Okay? It happens in our nature. If equal normal force applied over every unit surface of a body, then it undergoes a certain change in volume. Of course, we will get a change in volume. Here. Then the force opposing this change in volume per unit area is defined as a volume stress. Per unit area is a compulsory for us. When we are talking about types of stress, then per unit area is compulsory. Otherwise, it will be definition of a strain. So it is telling you when deformation force will be applied from each sides of a body, or you can say per unit surface, then what will happen? It will go inside. It will go under. So, okay, after removal, deforming force, when restoring force will be applied by this volumetric object, per unit area is our volumetric stress. I hope you understood it very well. Means when deformation force will be removed on this body, then this body will apply force which is a restoring force per unit area, on per unit area, so that it can come to the initial shape, okay, to the original shape. Okay, okay. So formula for this should be equal to F upon A, again restoring. This is the restoring force, and we can say pressure. Pressure. This is done about volumetric stress. Third type of stress, which is shear stress. This is a little bit different from the two types of stress which we studied. See, you see, observe over it. Shear stress. Shear stress. Whenever you hear this word, just understand shear is nothing but tangential force, tangential restoring force. Okay, this is nothing but tangential. We will apply force which should be tangential, not perpendicular, not horizontally, not vertically. Clear? So let's visualize it. This shear stress. This was body on object which is fixed with the surface of the earth. This is the body. When we applied force tangentially, like this force, which is the external force, then what will happen? Remember, bottom surface of the body is attached with the surface of the earth. It is not going to move at all. Now we are observing that when we apply force tangentially, then top surface of the body displaced, and it came over here. This was A, B, C, D. Now this is A, E, F. A, E, F, D. A, E, F, D. Here, how much it covered distance. So this thing we will get from this angle, and this angle is our shear stress. Both are equal. Now you have applied what? External force. After this, what will happen? After this, object will apply force. What will apply? Object will apply, and which will be restoring force. This is known as restoring force. But this object will come to the original shape when deformation force will be removed. Then it is possible to bring its initial shape. Without removal of the deforming force, it is not possible. Okay. So this theta is our what? Shear stress. So remember, let's say this is L and this is a del L. This is our change in length. Yeah, change in length. Remember, this BE will be equal to CF, and this AE will be equal to DF. AE will be equal to DF, and BE will be equal to CF, and this According to this, theta will be equal to theta. This both will be equal. Both will be equal. Okay. Okay. So it is saying, this is saying, when you applied of external force, okay, remove your deforming force, external force. Now I am going, object is saying, I am going to apply what restoring force so that I can regain my original configuration, my original shape. So what will happen? This will apply restoring force per unit area. Per unit area. Clear? You can say this shear stress is equal to theta. But here you can also write this as a tan theta is equal to, this tan theta is equal to base P upon B. P upon B. P is what? P is a L. Okay, P is a L. P is a L, which is a perpendicular. L upon dl. Okay, this is our shear stress. Now next thing, breaking stress. Breaking stress. Breaking stress. It says this stress required to cause the actual fracture of a material is called the breaking stress or ultimate strength. Yeah. Breaking means break a body, breaking body. This is telling you what is that force which is a requirement for the body so that it cannot regain its configuration per unit area. Okay, per unit area. What's required to break the body? For example, I have this wire. When I will apply deforming force on this object, and the amount of the force is more than requirement for this body, then what will happen? This wire will break. So that amount which is crossing the limit will be our requirement force, so that it can break body. Okay. So what is that force which is maximum to break body shape? Okay, so that it cannot come to the initial location, initial position. So our formula will be same. Breaking stress is equal to F restoring force upon A. But remember, this is not a restoring force. It will be, I think it should be external force. F force required to break the body. Now let's say dependence of breaking stress. Dependence of breaking stress. First we have nature of material. Even we are depend on nature of the material, because material has a different nature, so that I can regain my original configuration, my original shape. So what will happen? This will apply restoring force per unit area. Clear? You can say this shear stress is equal to theta, but here you can also write this as a tan theta is equal to, this tan theta is equal to base P upon B. P upon B. P is what? P is a L. Okay, P is a L. P is a L, which is a perpendicular. L upon dl. Okay, this is our shear stress. Now next thing, breaking stress. Breaking stress. Breaking stress. It says this stress required to cause the actual fracture of a material is called the breaking stress or ultimate strength. Yeah. Breaking means break a body, breaking body. This is telling you what is that force which is a requirement for the body so that it cannot regain its configuration per unit area. Okay, per unit area. What's required to break the body? For example, I have this wire. When I will apply deforming force on this object and the amount of the force is more than requirement for this body, then what will happen? This wire will break. So that amount which is crossing the limit will be our requirement force so that it can break body. Okay. So what is that force which is maximum to break body shape? Okay, so that it cannot come to the initial location. So our formula will be same. Breaking stress is equal to F restoring force upon A. But remember, this is not a restoring force. It will be, I think it should be external force. F force required to break the body. Now let's say dependence of breaking stress. Dependence of breaking stress. First we have nature of material. Even we are depend on nature of the material because material has a different nature.